Hi, and welcome to a couple videos on domain and range and functions. We're going to get started with some of the simple stuff. So what are we going to be doing today? We're going to be able to identify the domain and range of any object that we come across over these couple videos. Um, Today we're going to focus on the more simple situations, and then in the next video we'll get to the more complicated situations, which I think need their own video. So how are we going to do this? We're just going to figure out what are the x values and what are the y values. Why are we going to do this? Domain and range are super important. They help us understand the structure of functions, and they help us understand what's actually going on in the thing that we're working with. So let's go ahead and begin and talk about what actually these things represent. You probably have heard of them before, domain and range, but what do they actually mean? Well, domain is basically just what am I putting into the function? What are all the things that make sense to actually go into the function? What is it that I can take and throw in there? Like, if we think about the square root of x, if the only numbers that we're even bothering to consider in, algebra 1 are real numbers, then the domain is going to be all the numbers that are 0 and greater. We can't put in a negative number because that doesn't make sense for our function. What's the square root of -2? That doesn't make sense. Likewise, the range is all the outputs. If I take all those numbers that I identified to go in, what does that mean I get out? When I plug in 4 into the square root function, what do I get out of it? I get 2. If I plug in 64 into the square root function, what do I get out of it? I get 8. If I plug in 10 into the square root function, what do I get? I get a decimal that's somewhere in between 3 and 4, right? We don't have to know that exactly, but we know that there's an output for that input, okay? And so when we're trying to identify the domain, I think that's the easier part, almost always. It was just, okay, what goes in? Sometimes we're going to ask the question, hey, what can't we put in? And then for the range, we're asking, okay, for all the things that we plug in, what ends up coming out? All right, so let's talk about like how. All right, so the only one I would say that's even remotely difficult is when you've got a function equation. It's going to actually require you to calculate something out, but pretty much everything else that you do here is basically looking at what you're given, pointing at it and going, oh, that one. All right, so it's not gonna be by any stretch of the imagination difficult. I just want to get that out of the way right now. Everything that we're going to do today especially is literally just looking at information and just saying, okay, these. All right, so let's jump in, starting out with mapping diagrams. So this is basically a way to represent a relationship, the stuff that's in the domain, get the arrow that goes to the stuff in the range. So when I write this down, okay, what's my domain? The way I do it is like this. I always a capital D to tell me, hey, this is my domain. And then I'm going to write a set. Get the curly braces, and I'm going to list all of the different things that are in the domain. Here I've got -1, 0, 1, 2, and 3. So those are my list of numbers that it makes sense to use for this particular relation, which happens to be a function, and we'll talk more about that later. And so look, I just took the numbers that are in the domain, and I copied them down to my answer here. I'm going to do the same thing with the numbers in the range. Here I've got 3, 5, 11, and 21. And that's it. Your answer should pretty much always look like this in a situation like this, where you're just given a set of numbers to work with. Just write down the set of numbers. You'll notice that technically 5 is represented in this range twice. Both -1 and +1 map to the number 5, right? The arrow goes from -1 to 5. The arrow also goes from 1 to 5. We don't have to repeat 5 twice. And if you see it happening more than once, you don't have to repeat it at all. You only ever want to see the same number appear once, because otherwise that's redundant and you don't want to do that. All right? So now it's your turn. We're going to find the domain and the range. Now notice domain is listed with X, range listed with Y. Take a minute or so, try and figure out what's in the domain and what's in the range. Okay, so let's look at what's in our domain. We've got -1, 0, 1, 2, and 8. So for our domain, we're going to put -1, 0, 1, 2, and 8. And you know, if you're having trouble, look how badly I did that close bracket. If you're having trouble making your brackets, basically think about it like a extra squiggly 3. You know, put a little extra hook in the middle, and then complete your 3. Or a backwards, right? This one's easier for me because it doesn't interfere with my muscle memory for writing the number. See, it's always bad. I can never do it well. But just think about it. It's a 3 squiggle 3. All right. Let's do our range. Ooh, I like how that R turned out. That's pretty. -3, -2, 2, and 3. And again, don't be confused by the fact that 2 has 2 different guys go into it. -1 goes to 2, but also 0 goes to 2. It doesn't matter. We just care about what the numbers are in this set here. -3, -2, 2, and see, getting confused trying to write the number 3 because it's like 3. There we go. It's like, no, I'm trying to close the parentheses. Trying to close the bracket here. That's okay. All right, so here I have my domain. These 5 numbers, -1, 0, 1, 2, and 8. And here I have the range. These 4 numbers, -3, -2, 2, and 3. All right, let's keep on going. So once again, take a minute, try and figure out what's in the domain, what's in the range. Okay, so one thing that you're going to find is different in this case, and again, we'll not talk about this today, but notice in this case, -4 has 2 people going to it. It still doesn't matter. We're not going to write it any differently, but this is a special situation. We would identify this as not being a function because -4 is not allowed to have multiple things coming from it. So that's just something we'll learn about in a little bit. But again, we're going to write down our domain. These 4 numbers, -4, 0, 3, and 5. And then our range. These numbers, -3, -2, 0, 1, and 7. And that's all there is to it. It's just what numbers are in there. All right? Let's go forward. So here, now instead of being given a mapping diagram, I've given you a set of points. And you know, these points can come in an actual physical set as ordered pairs, They could come in a, an input-output diagram, whatever it is, however it is that they give it to you, this is what we're talking about. Notice that the x values are always the first number, the y values are always the second number. That is always and forever going to be true. If you get backwards, it's going to be wrong. So the x values are your domain, the y values are your range. So, sometimes it helps to, circle the x values just to call attention to them. You could separately underline the y values so that you know that it's a different thing. And again, I want to point out, notice -2 came up twice. It doesn't matter. We don't care how many times it comes up. We just want to know if it's there. So -2 comes up, 0 comes up, 1 comes up, and 3 comes up. That's our domain. We don't care if it happens more than once. We just care that it happens. And now with our range, we've got 1, 3, -3, and 4, and 1. Well, 1 happened twice again. We don't care that 1 happens twice. We're not going to write it twice. It doesn't matter that it happened twice. We just want to write what numbers are actually supposed to be there. Now, if we go through, some people are going to be like, well, put them in numerical order. Awesome, great. It doesn't have to be. But, you could do 1, 3, -3, 4. You could do -3, 1, 3, 4, however you want to do it, as long as those are the 4 numbers that are in your curly braces and labeled as your range, you know that you got the answer correct as far as I'm concerned, okay? So notice, same idea, but now it's just written as an input-output table. Okay, so let's list our domain. Remember, domain is our possible x values, so -3, all the integers all the way to +3, so we'll write those down. And here I go again. Make sure that you do your number 3s correctly. And then now, again, it's okay that numbers happen to repeat. We just don't want to write them. So, and you don't have to put them in numerical order. I'm going to do it just, for that weird flex. So -3 is in there, -2 is in there, -1 is in there, 1, 2, and 4. Those are our numbers. All right? And again, if you just wanted to list them out the way that they are, 1, -2, 2, 4, -3, and -1. Again, you don't want to repeat the number -2. No reason to do that. You can have that as well. Try another one. Here, the only difference is that now the XY table is vertical instead of horizontal, and that's okay. So go ahead and list them out. Domain, range. 0, 1, 2, 3, and 4 are our x values. Our y values are 0, 1, 4, 9, and 16. Again, these we should be not having any trouble with. This should be very simple for us. And even here, if it helps, you can actually write down what these points are, but this is just the exact same problem, just written out as a picture instead of the actual numbers written down on a chart or in a set. They're just in a picture. So if it helps, you've got your x-axis, you've got your y-axis. Remember the x value comes first, so 1, 2, comma 1. right? We go x first, 1, 2, and then we find the y, which is up 1. Do the same thing here, 2, -4. And if you're having trouble identifying where these are, there's another video on this channel somewhere on how to find these points. I'll have it in a little card up here somewhere. We got -5, -4 here. We've got -5, 1. We've got -2, 3. And again, just domains all your x values, ranges all your y values. So let's look. We've got -5. That's an x value. Next x value we see is -2. And then next x value is 2. And those are the only 3 different x values that we see. So those are the only ones we're going to write down. Range we're going to do as well. Let's start from the bottom, work our way to the top. The first y value we see is -4. We go up. The next y value we see is +1. And the last y value we see is 3. All right? Pretty simple. Let's keep on going. So now, no longer just pieces, right? Now we actually have a whole curve that we're looking at. We have a piece of a continuous, and I say continuous because it's this whole curvy line, right? It's a curve, continuous, because it starts somewhere, and you can't pick up your pencil to draw all the way to here. You know what I mean? So, where does this curve start on the x-axis? I always go from left to right. That makes my life super easy. So let's work horizontally first. What's the leftmost number? Well, that's -3, right? And that's an open circle, so we know that it's not included. So we know that it's not included. We'll take care of that with our final piece here. Now we keep it going, and where's the rightmost thing? Well, that's here, right? At 1, right? So the rightmost thing happens at +1. Now, we're going to talk about a number of different ways to do this. If you prefer set builder notation, we're saying the domain is all the x values such that x is between -3 and 1. Now notice the difference here. Strictly less than because it's an open circle, and a less than or equal to sign because it's a closed circle. Keep that in mind when you're going through. Open circle, not equal to. Closed circle, equal to. All right, let's do the same thing going up. Let's do the same thing going vertical. Let's use a different color so that we can tell the difference. So again, let's start at the bottom. What's the lowest thing we see? It's either this or this, right? Oh, look, they're at the same spot. At -4, right? And anytime you see just like a whole piece of a curve there, you're to presume that that is a closed circle, okay? It touches. It touches. So we got a closed circle here and here. So when we put that into our answer, it's going to be equal to as well as, right? Now, take a look at this. The top is at 0, right? And here there's an open circle, and here that would be a closed circle. So I'm sure the big question here is, well, which one wins? Does the open circle win or does the closed circle win? We have to choose, right? Is it there or is it not there? And the answer is, all we're asking is, does this value work for y somewhere, anywhere? It may not work in other places, but if it works in any place, then we're okay. So like, yeah, it doesn't work here. The point -3, 0 is not a part of this curve, technically, right? It's an open circle, it's not a part of it. But on the other hand, the point 0, 0 totally is. So even though this is an open circle, closed circles always win. And I'm going to write that down here. Closed circles always win. So if ever you're stuck in a situation like this, oh, well, okay, the highest point, there's two of them, and one of them's open and one of them's closed. Well, what do? Always closed. So in this case, we don't care about that anymore. That's we're gonna yeet that. We don't care about that. We only care about this one here because closed circles always win. So our range, even though there's an open circle in there, it's covered. So our y values, our lowest y value is -4. Our highest y value is 0. And they're both included. All right? Now, that is one way of writing this out. This is what we call set builder notation. And if you want to use that, you are always welcome to use that for me. This is totally fine. This works great. So basically what you've got is the braces, and in the middle, x. The line here means so that x is between -3 and +1, right? And then the range here with the curly braces, y, so that y is between -4 and 0. That's one way of writing this. The other way of writing this is using what's called interval notation. So instead of making a set, we're going to make a little ordered pair here. If the number is included, next to that number we put a square bracket. So 1 was included, it's a closed circle, 1 gets a square bracket. The left one here, -3, was not included on domain for the x values, right? Nowhere is there a -3. So when it's not included, we call that a parentheses. And then for range, both of them were included, equal to and equal to, so we are going to have both of those be brackets. All right, and this is called interval notation. These two ways of writing it are all interchangeable. They mean the exact same thing. Any person who understood mathematics to this level would be able to look at those two things and say, okay, I read this correctly, I read that correctly, they mean the same thing. So don't be worried about which one you want to pick. Sometimes the online homework will force you to make a choice to do it one particular way because that's the way that they've been programmed to require it. But when you are turning in work to me, then you can always expect that whether you give me set builder notation or interval notation, you are correct as long as you give me the right thing, right? Make sure to identify where it's going to be a parentheses, where it's going to be a bracket. All right? And we'll see more of these in a little bit, so we'll talk more about this. So let's do another one. So one of the things I want you to take away from this is not to let arrows trick you. You notice how the arrows sort of stop here at 5? No, they don't. Arrows mean that they go on forever. So if you're ever in a situation where you're looking at this picture and asking yourself, well, the arrows are only up to here, that's confusing. Take a second. Continue upward. Now, the other thing that I want to really sort of set into you right now is that notice how this is going to the right. It's going to keep going to the right. It's just going upwards faster and faster and faster and faster and faster. If I had a bigger picture, I could see where this curve went over like all the way to 10. It would be way up there. Way up there. But like, you'd get there eventually. So like, even though it doesn't look like it right now, eventually, if you were patient enough in your drawing, you'd eventually find a place where 10 gets hit by this function. So especially when you see arrows going upward up to infinity, you can presume that they're trending not just up, but also to the right. You know, or not just down, but also to the right or to the left or whatever. So like here, the x values, we're going all the way. We're going all the way. So the way, how would I do this? Because that means that every x value is covered on this number line, all the way from negative infinity to positive infinity. Well, again, there's going to be a number of different ways, and I'm not going to tell you which one I think is best, because I think they're all good in their own way, but I'm going to show you a couple different options. So one way you could do this with set builder notation. No, you wouldn't use set builder notation. Here's what you would do. Let's use interval notation for this one, because we're going from negative infinity to positive infinity. I'm just going to make negative infinity to positive infinity. Now the question becomes, well, is that supposed to be a parentheses or a bracket? Well, the thing of it is, as we are conceiving of it in this situation, negative infinity isn't really being used as a number per se. Like, we're not saying, because there's no number that we can plot a point on and say, hey, this is negative infinity. I have a friend who would argue with me about that for about a day and a half, but with the way that we conceive of this and the way that it has been sort of conventionally decided that we're going to communicate this, anytime one of your things is infinity or negative infinity, you're going to use parentheses. All right, that's probably the most politically correct way that I can say that, because, you know, there are reasons why we might want to talk differently about infinity, and maybe we'll get to that much later on. But for now, the standard convention is, and you know, like, you go and try and do your homework and you put in a bracket when you're supposed to put a parentheses here, it will mark it wrong, and there will be no saving, because I told you just now, if you see an infinity sign, you are to presume that you are to put a parentheses. All right? Now, so that's the x values. Now let's look at the y values. The easiest thing to do is to find where there's air and ignore that part. We don't care about air. We don't care about where there's no y values. We don't care about where we can just, you know, run our hand underneath. That's not the part we want. We want where there's actually line, right? Where this blue line is. So let's look at the blue line. Where's the lowest blue line part? Here, right? The lowest blue line part is right here. There's nothing below -4. And again, remember, it dipped down and it touched. This is a closed circle. every time. And then look, what's happening? It's going up. It's going up, right? 5 ever. It is going all the way up to infinity with both of these little branches, right? It's not going down ever. It's going up, 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 uppity, up, 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 up. All the way to infinity. So how do we write that down? Well, what's the lowest number? -4. Again, it's included, it's a closed circle, so we use a bracket. What's the highest number? Well, it just keeps going. It's going to keep on going and going and going and going and going. It will approach infinity. It will keep on going forever. A million, a billion, a trillion, a quadrillion, etc., and keep on going for decades and centuries and millennia after that, if you kept counting. But we won't. We'll just put infinity, and remember, infinity always gets a parentheses if we're using interval notation. That is the way that it was decided upon. We can offload that, that existential crisis onto the people who actually plan to study and make philosophical decisions about that. We don't have to. We see an infinity sign in our interval notation. We just put a parentheses and we move on with our lives. Okay, that's what somebody told us to do. So for the domain, notice negative infinity to positive infinity, that's everything, right? Nothing is skipped. We're not missing anything. So another way you could write the domain, the range is going to be the same. But you could write all real numbers or you could also write this as, and again, the range didn't change. You could also write this as a special extra fancy R. It's like an R, but the vertical stick part of the R is bold, kind of like this. That's a fancy symbol that means all real numbers. These are, again, all of these are different ways to do it. I'm just showing you this way because why not? You'd never have to use this symbol over here if you don't want to. If writing out the phrase all real numbers makes more sense and feels better than writing out negative infinity to positive infinity in interval notation, please feel free to do that. That's totally great. That's totally fine. No one is going to stop you. All right, let's keep on going. So I really liked this picture, the way that they did domain, range, with the different arrows. So notice here the way that they have this ray. It starts here at -5 and it goes all the way. Remember, arrows mean we go to infinity, right? So our domain starts and includes -5, goes all the way up to infinity. Notice again, infinity gets a parentheses. Range. It starts at, let me make sure I've got the right color here. There we go. Notice the range, the y value starts at 5, right? And it goes down to -infinity, right? Now, we want to make sure that we put things in order. The top number should go on the right, the bottom number should go on the left. So just be aware of that. -infinity always comes first, like this. Even though the arrow is starting here and going that way, don't let that confuse you. Smaller numbers go on the left, bigger numbers go on the right. Okay? And then, you know, again, if you would rather use your set builder notation, x such that, well, it goes from -5 on up, so x is greater than or equal to -5. Your range, that's your y values. And here, starts at 5 and goes down. Y is less than or equal to 5. Yeah, again, are either of these two superior to the other? No. Is one gonna hit better with you? Probably. Use that one. That's all I'm saying about that. Okay, so take a minute, think about this one. Okay, so notice arrows, right? There's an arrow here, there's an arrow here. The x values, they're going all the way, both ways, just like in that last, that one a couple times ago we had, right? So here the domain is from -infinity to +infinity because every x value is covered. The range, again, every number is covered, right? Every y value is covered. So the range is also -infinity to +infinity. All right. Here's a complicated one. I wanted to put one like this on here. So let's start with the x values. So look, you got all these open circles. Those should be what we sort of base our stuff on, right? You got an open circle at -1. -1 is not part of the things that work for x. Likewise, if we move forward, see how 4 also has only open circles on it. But everything else is covered, right? Arrows going all the way this way. Arrow means we're going all the way this way. This whole line in the middle's got us covered really nicely. So the only thing that's not included is -1 and +4. So the way we would do this is basically we're going to split this up into 3 little intervals. -4, -infinity all the way to -1. And -1 is not included, otherwise that would have been a bracket, but it's not included, so it's parentheses. Now I'm gonna take this one, I'm gonna connect it. And the symbol we use as connect is a U, and that stands for union. -1 all the way to +4, that's the next set of intervals, right? And neither of those is included either, right? There's no spot where -1 has a closed circle. There's no spot where 4 has a closed circle. And then finally, our last interval, which we're going to union together, is 4 all the way up to infinity. So again, 4 is an open circle, so we don't worry about that. Parentheses, and then we go to infinity. And infinities are always parentheses as well. All right, so that's our domain. Now let's do the exact same thing with the range. So once again, we see the arrow going down, right? The difference is on the y-axis, these things are overlapping. Where's our first open circle that we see? Well, here and here. But notice, this spot right here, also, and any of these too, right? All these points here, these are also closed circles, right? So do we care that -2 has an open circle? No. Closed circles always win. So, these open circles get yeeted. And we move on. -1, there's our next open circle. But unlike the rest of them, see how -1 doesn't have any other closed circles on that latitude, that horizontal line, right? So now we actually care, right? Now, oh, so it stops here. So let's put that part on right now. It goes all the way down, -infinity, comes all the way up to 1. And by 1, I mean -1, right? And now we're going to have a whole other thing coming up here. So let's, once again, a union. And here in the middle is like this no man's land where there's nothing. There's nothing. You can ignore that. Let's go to the next spot where we actually see part of our curve vertically. Nothing, 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 until we get to the number 2, right? That's where our next open circle is. And again, we look on that horizontal piece and we see that there's no closed circles to beat it out. So 2 is going to be an open circle. And then if we remember, arrows mean going forever. So it goes all the way up to infinity. All right. And again, there's going to be certain situations where if we do interval notation versus set builder versus whatever, that there's going to be an easier thing to choose. Interval notation, 9 times out of 10 is going to be better. Going to be totally honest with you. All right, let's move on. Take a look at this one. So now, the x values are the ones where there's a big gap, right? So let's take care of the x values first. We got an open circle at -5, and it has no other x values. No other things going this way. Forgive my terrible squiggly line, but we want that to be straight. But, you know, you get the idea. So this is there, right? And then it keeps on going all the way to where? Well, here's where it stops, right? At -2. So our first little interval for our domain, -5, and notice it's parentheses because it's an open circle, to -2. That's a closed circle, so it's a bracket. And union, what's the other thing? Well, it starts back up at 1 again, right? And it is a closed circle. And it's continuous, it keeps on going until it gets to 4 where it stops on another closed circle. So remember, closed circles are brackets, so from 1 to 4. And then the range, well, let's do the exact same thing. Let's use a different color though. Range. There we go. So where does it start on the y? Nothing, 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 ding, at -4. That's where it starts. Where does it keep on going to? Well, it keeps on going for sure all the way up to here, right? But also, this one starts here. These are overlapping, right? Well, once again, it doesn't matter if we've got multiples. We just care about where it is. So if you want to, you can pretend like this is one whole thing that doesn't end until you get all the way up to 3, because it's all just one whole thing, right? So here, from -4 all the way up to 3, but look, open circle and nothing to beat it, so negative 4 is a bracket, and positive 3, which is our top, is a parentheses, open circle. All right? So, next time we're going to talk about how to do this with function equations. We'll talk about how to deal with all of that good stuff. If you have any questions, please feel free to email me. My email is right here, and I check it all the time. So if you have any questions, send me an email, let me know, and I'll see you next time. Have a good one.